Dilutions are really useful because one thing that they allow us to do is solve for the concentration of solutions after you've diluted them. But to know the concentration, you need to know the exact dilution. So let's say we have a stock tube of antibiotic, and we know that the concentration of this antibiotic is 100 milligrams per milliliter, or 100 mg per mil. Let's say we wanted to make a dilution of this antibiotic. So we could take another tube, and let's say we wanted to make a 1 to 100 dilution. Of this antibiotic. Okay. So first we're going to ask ourselves, what is the total volume? So let's say we want to make a total volume of this diluted antibiotic in 1 milliliter total volume. Okay. So how would we do this? Okay. Our antibiotic stock, we're going to need some volume of it, and then we're going to dilute it in our diluent, and let's say this is water. Okay. Our dilution is 1 over 100. We know what the total volume is. In this case, it's 1 milliliter. And so we're going to solve for the volume of the antibiotic. So let's solve for the volume of the antibiotic. If we cross multiply, divide each side by 100, and the volume of the antibiotic is 1 over 100 milliliters, which is the same as saying 0.01 milliliters. So if we go back to our tube over here, to make this 1 to 100 dilution of the antibiotic, we would add 0.01 milliliters of the antibiotic to a new tube. Okay. So what's the rest of that volume going to be? Well, we're diluting it in water, so it's going to be some volume of water. And keep in mind that the total volume is 1 milliliter. And so to solve for the amount of water, the volume of water is going to be equal to 1 milliliter minus 0.01 milliliters, which is equal to 0.99 milliliters. You might be making a dilution in a very large volume, or you might be making a dilution in a much smaller volume. This depends on how much of it you'll need. So for the sake of practice problems, typically you'll be given the constraints of the problem. So for example, you might be given the total volume and the volume of the concentrated solution that you are going to add, and then you're asked to solve for the dilution. You might also be given the dilution and the total volume, and you have to solve for the volume of the concentrated solution that you need. So in either of these situations, right, just keep in mind this equation. Dilution equals volume of concentrated solution divided by the total volume. So going back to the example of the antibiotic, we started off with a stock solution and we made a 1 to 100 dilution of this. Okay? So you can ask ourselves and calculate, well, what's the concentration of this diluted solution? So to solve for this, right, you would just multiply the stock concentration times the dilution. So in this case, your diluted antibiotic is going to have a concentration of the initial concentration times the dilution, which in this case is 1/100. So now the concentration of this diluted antibiotic is 1 mg per mil. When you're doing these types of problems, you want to ask yourself, does this make sense? If you start off with a solution that's more concentrated, when you make a dilution of that, ask yourself, should the concentration get larger or should it get smaller? If something is more dilute, the concentration should get smaller. So in this case, the diluted antibiotic has a concentration of 1 mg per mil. Okay. Up until now, we've been using the term dilution, which is the volume of the concentrated solution divided by the total volume. But I wanted to introduce another important term in biology or in making dilutions, which is dilution factor. Dilution factor is very similar to dilutions. It's related to dilutions, but it's not the same thing. Dilution factor is 1 divided by the dilution. So let's take an example where you made a dilution that is 1/100. The dilution factor would be 1 divided by the dilution. So in this case, the dilution factor equals 100. Another way of thinking about this is that the dilution factor refers to the number or the fold in which you've made your solution more dilute. Okay. So it's important to keep in mind that in some instances, you'll be working with the dilution, which is the volume of the concentrated solution divided by the total volume. And in other cases, you might reference the dilution factor, which is 1/dilution. So just in terms of this naming, let's say you have a dilution that is equal to 1/50,000. The dilution factor equals 50,000. Okay. And we can write this in scientific notation just for kicks. The dilution factor equals 5 times 10 to the 4.